Hi folks, welcome back to Math with Captain Rod. I'm making this video to be just an introduction to a couple important concepts here, what are called sequences and series. So we're going to start with a sequence here. So a sequence is an ordered list of numbers. So for example, this list of numbers right here, 3, 5, 7, 9, is an example of a sequence. Sequences can be either finite or infinite. So in this example, this list has four values here, a 3, a 5, a 7, a 9. Right? But sequences can also be infinite, and perhaps we have another sequence where this just kind of goes on forever. The ... means that this just keeps going and going and going and going. You know, the next one, hopefully you recognize where the pattern came from. The next one will be 11, 13, 15, etc. It just goes on and on and on. Now, sequences can be usually described by some sort of equation here. So in the example I gave here, each individual value, like this one, we could call this maybe A1, this one A2, this one A3, A4, etc. And over here in this sequence, we only have 4 values for A. However, here this one goes on forever and ever and ever. We have an A5, A6, A7. Well, this formula that I wrote out, a sub n equals 3 plus 2 times n minus 1, is a formula that will give us the value of whatever number, whatever a sub n we want anywhere in the sequence. You'll notice that if you put in n equals 1, we would be getting a1, and 1 minus 1 is 0, and we get a 3 here out of this, for both cases, finite or not. And if I put in, say, 2, then a2 would be 2 plus 2 times n minus 1, which is going to give us this one, the 5. And then a3 we would get by putting a 3 here. And 3 plus 2 times, let's see, which one was I doing here? 3. That'd be a 2, 4, and that would give us a 7, right? And so forth. So you'll notice that I have a formula here that will tell me the value of any number in the sequence. Now, sequences come in all types of flavors here. There's really an infinite possible number of equations I can write to describe a sequence. There's 2 very important ones that we'll spend some time talking about in the upcoming weeks here, and those are what are called arithmetic sequences and geometric sequences. Arithmetic sequences occur when the difference between these is some constant. See how to get from 3 to 5 we add 2, to get from 5 to 7 we add 2, to get from 7 to 9 we add 2, and so forth. You could be adding any constant, I'll say d, to get from one value to the other. D could be bigger than 1, it can be less than 1, it can be a fraction, it can be negative. As long as it's constant, then what we have is an arithmetic sequence. And therefore, the arithmetic sequence, the nth term of the sequence, can be calculated using this formula here, where the a sub o is just some number. In this case, in this example, that value was 3. Okay. Sometimes sequences are generated not by the addition of some value, but by the multiplication of some value. So for example, if I look at this sequence here, 3, 9, 27, 81, here what I'm doing is we're getting from here to here by multiplying by 3, and then from here to here multiplying by 3, and then from here to here multiplying by 3. Now I have put the ... indicating this is meant to be, in my example, an infinite sequence. So another example down here, maybe the sequence looks like this, 3, 1, 1/3, 1/9, and so forth. So here what we're doing to get from here to here, that was a multiplication by 1/3. From here to here, multiplication by 1/3. From here to here, multiplication by 1/3, and so forth. So a geometric sequence is a sequence that's generated by the multiplication of some constant going from one term in the sequence to another. So again, this was just meant to be an introductory video on sequences and series. Oh, whoops. We should talk about the series part. Okay. So a series, let me get rid of this. We're not going to need this anymore. A series, what that is it's a sum of a sequence. So if I were to take this guy right here, and I were to take 3 plus 5 plus 7 plus 9, I'm getting a sum of a sequence, and there's a little bit of a notation that goes with that. This is usually called maybe S sub n. This is the sum over the sequence from n equals 1 to 4. Now there's also some notation that goes with this. This symbol right here is the Greek letter called sigma, and it means sum. So in this example here, what we are doing is we are summing up from n equals 1 to 4 all these a sub n terms, where the a sub n would be described by this formula in this example. So a sequence is an ordered list of numbers, and a series is a sum of a sequence. Now sometimes this sum will give you a number, and it will be finite. Sometimes it won't. If we were to do some sort of sum over this sequence, we wouldn't get a value out of that. The value would be infinite, because these things just keep getting bigger and bigger and bigger forever and ever and ever and ever. Now, just because this gets bigger and bigger and bigger forever, just because this goes on forever does not mean that this series does not have a finite value. You can have values, some sort of sum from n equals 1 to infinity over some sort of a sub n here, and this could be infinite. There could be an infinite number of terms, but basically what can happen is if the a sub n goes to 0 fast enough, this sum can still be finite. So don't fall into the trap of believing just because we have an infinite number of things to add that they add to infinity. They can in fact add to a numerical value or a constant, and we'll learn about that in upcoming videos. So this is just meant to be an introductory video over sequences and series. Long story short, a sequence is an ordered list of numbers, and a series is a sum of a sequence. Sequences, they come in all types of shapes and sizes, but the two most common that we'll talk about here are arithmetic and geometric. And the big difference is that in arithmetic sequences, the a sub n values are generated by the addition of some constant, like in this example, that constant was 2. Whereas in geometric series, the a sub n's are generated by the multiplication of some constant, right? So hope this video helps give you at least a reasonable flavor of what these things are. Have a nice day.